everyone. Uh, Myself, Nikhil Kushwaha. Yeah, I'm the presenter today. Uh, I'm presenting basically one of the research paper given us, uh, entitled AutoWebGLM. Basically, this is based on web navigating agent. Uh, uh, you can say that this is basically a general language model, basically a large language model, which is based on chat GLM with a 6 billion parameters. Uh, mm, the title entitle uh, is nothing but you can see here Bootstrap and reinforce a large language model based web navigating agent. These are the like my streamline review of this paper. You can see that I'm following the introduction, the related work regarding the past work regarding the web navigating agent, and the some of experiments and with the result presented in the paper, and also follow up with a conclusion. So coming up next, let's go for an introduction of a quick introduction what it tries to solve. Basically, uh, as we know that this is um, a general language model, basically designed for web navigation to do some tasks like to automate basically the real world web pages. So basically the uh, issues which is targeted for the improvement by the like prior versions like WebGLM based on which is also implemented by this benchmark only. So it tries to solve the versatility of actions on web pages, which basically means that when the it tries to solve the uh, user uh, things like when a particular user is engaging to a particular website, then he might click some buttons, click some links, fill up the forms, scrolling or navigation through any other ways possible. Or also, uh, we know that current web navigation agent struggle to handle this diversity. So this basically solves this type of issues, which is not solved by previous or past agents. And the second thing, the HTML text exceeding model processing capacity. So we know the web pages are designed with heavy HTML code. So the HTML content of web pages are very much extensive and complex. So we know often uh, so many existing language model having so much of like the surpassing the processing capacity, like tuned with or trained with billions of parameters, but still for the model it is difficult. It was difficult actually to understand and navigate through the web page content efficiently. So this auto web JLM model handles it in an effective manner. Uh, some more like it solves a complexity of decision making because we know the navigation uh, involves some strong decisions in an open domain environment where agent must interpret and act upon a wide range of information and also potential actions. So this complexity makes uh, the uh, the agents to perform the task accurately or effectively. We can say so. This is also handled by this particular web navigating agent. Well, uh, some more uh, uh, things which it tries to solve is the integration of web navigation tasks like uh, uh, like when we use previous navigation agents, uh, uh, we can see or we can experience that they may perform well on isolated tasks, but fail to manage complex workflows. So basically, that require a combination of action and decision-making steps. So to seamlessly integrate multiple web navigation tasks, this is developed over some quite interesting approaches. So it basically integrate different approaches or different tasks and perform well over different the past navigation agents or navigation models. And also it tries to solve like it adapts the uh, situation or handle the current particular website or web page in real time. Like we know web pages are dynamic and change frequently. Depends on the developer what he tried to change for a website. So the existing model often lack the adaptability to cope with these real-time changes, and also leading to reduced accuracy because at the time of training, like model training, the data set which is used to train a particular model is different. It might possible that on real-time testing with a different scenario of website with a different like because we know that CSS and all those front end things uh, keep evolving. So it, it might get a problem for a web navigation agents to uh, give a proper efficient response on that evolving technology. So it is very much required to adapt the real-time scenario and real-time websites or web pages. And also we know that web pages are coming up with various language and interface designs. So it may confuse the language models not specifically trained to handle such diversity. So this also become a serious issue to solve basically by the web navigation agents. So multilingual is also becoming a much more serious problem. So basically, this auto web GLM model is built on two languages, English and Chinese. Uh, so because Chat GLM 6 billion parameters also having uh, uh, bigger corpus is also trained on English and uh, Chinese corpus. So coming up next, what are the approaches to solve these problems? So basically, this AutoWeb GLM, uh, this model is using HTML simplification algorithm, which is basically a newer algorithm that reduce some of the complexity of web page content by uh, by filtering out the essential information is, uh, so that this will help the model to process and understand the web pages more efficiently. And also, we can see that it is used some of the steps like DOM tree reduction to do this like filtering. The document object model tree of the web page is parsed to filter out the non-essential elements, which is not required by the web agent for such complex decision-making thing. Uh, and also it follows a hybrid human AI method, basically, which is a combined approach where human expertise is used alongside AI techniques to create high quality training data. Like human feedback, it is like keep evolving from a human feedback. When we are giving a prompt, then basically the model learns from the human prompt. Like basically it thinks basically it use the curriculum learning, like what human also use. Small child if sees a thing that this is a fact, this this thing to do or this thing not to do, and that small child memorize it and keep it for the future actions, like understand the things what to do and what not to do, how to tackle a problem. This model also work like that. Like this is also called curriculum learning. Just like a human brain, what how human brain adapts, the same the model also adapt to learn progressively from simpler to more complex tasks. Uh, uh, we can also uh, say something like it also use reinforcement learning, because we know there are some algorithm like proximal policy optimization and soft actor critic, and some more algorithm of reinforcement learning which enables the model to learn from its own mistake by training. Like at the time of training only, if the model is more biased toward anything or biased toward any particular data which is being provided to the model, then definitely the model is gonna learn from its mistake that what to follow or what not to follow. Basically, these techniques were used to bootstrap the model, improves its capability to comprehend web pages, perform some browser operations, and decompose the task efficiently. And also approaches like adapting the dynamic web pages, which is quite the problem in previous. I already told that in previous web navigation agents, they suffer a problem of being processing the dynamic web pages behavior, the dynamic behavior of web pages. So this reinforcement learning and that rejects sampling technique used by like this AutoWebGLM model, which enhance its ability to adapt real-time changes. So yeah, as this model is learning real time, because uh, what I what this model is basically on to uh, follow the curriculum learning. Yeah, so curriculum learning provides that real time learning, like what I also already explained, that example of a child learning from like observing the patterns and observing the environment, and like so like basically it learns like just like a small child real time. It will keep evolving itself from prior its before stages to better stages like in future aspects. Also, it follows task decomposition. It breaks down some complex navigation tasks into a simpler subtasks, which is quite followed by most of the agents. So what are the challenges here? So we know that HTML simplification algorithm is quite challenging to like to follow this DOM tree reduction thing. It's a bit challenging. So this basic challenge, like to ensure that HTML retains all necessary information. Basically, it is not required to take like filtering the information as omitting the necessary information. Like we should not, like omit the model should not omit the uh, necessary information at the time of filtering. It should take care that what the provided user input, like query like what is the weather today. If the targeted task it is to ask like what is the weather today, then definitely it should provide the weather of a particular region. It should not omit the other information provided in the website for the navigation of a website based on a weather. And also to decompose the smaller tasks, web navigation tasks into manageable steps is also quite challenging, because we know for such a large language model, basically it follows this type of approach. So yeah, it's also a challenge for this. and handling the variability and unpredictability of actual web pages and user interactions. We know there are so many things implemented on the website, like redirection, or like we know that so many websites are generated manual pop-ups, and so many things are implemented on the websites, uh, and ads also implemented on the website or web pages. So to filter out these type of problem, like filtering the ad blockers, using the ad thing to block, and filtering out the uh, not required information from the website, it follows these things to overcome it. So basically, AutoWebGLM methodology follows the two key strategies, also which solves the all of the problem of this. So the model is designed to mimic the human web browsing behavior, like what a human is uh, doing at the time of browsing. Like, say, for example, if a human is searching for a gift, like Christmas gift, or for a watch, or for a bicycle, or for anything in Amazon, then definitely human will give a prompt in a Google search, then tap that link, and tap that link, and go on the Amazon and log in and prompt the password and all those things. This is basically a general human behavior at the time of web browsing. So the inspiration of this AutoWeb GLM methodology is to mimic this particular behavior, how the human mind is processed for a particular task. This model also wants to replicate the same thing, what human brain or human have intended to. So also it follows a bootstrap development, like utilize what I already say, utilize reinforcement learning to like continuously improve the model performance. Basically, it's online learning, or kind of online learning, or live learning, we can call this. So now you can see this uh, basic workflow of this GLM web GLM model. Uh, so you can see uh, that on the right side, the real world environment and virtual environment is that these are the things which is take like some sort of rules are uh, already defined, so that data can be extracted from that real world based scenarios, which is now then formatted by some formatters, and then uh, given to the language model, like LM agent, language model agent, which process the information. And we know that the in the agent side, you can see the agent is learning continuously to understand and manipulate the web pages. Manipulation basically handles that things which I uh, uh, told, that advertisement things, and that pop-up things, and redirection things, because so many websites redirect by its own. So these are things that LM model should tackle to give efficient result. And also it learns from its own mistake and uses the rejection sampling fine tuning so to enhance the proficiency in the web environment. And basically when the at the time of framework, like you can see inside that LM agent, the process is going on that when after the collecting of data, it filtered out that the HTML segment and automated the program and think like HTML parser, and to use the tools to filter out some things. The tools like OCR module, like to enhance to capture the pictures present inside the web pages. Basically, that OCR model is used for that. And some tools like HTML parser used to parse the HTML content, which is then uh, passed by these tools to that observation spaces, and then after the observation spaces, it recalls that what are the previous actions I performed for this type of things, and what are my previous learnings from this type of my uh, like this type of my approaches. So based on that, this agent will decide that what to uh, output, what to give as an output to the user. And based on these all workflow, doing this and these all things, this perform uh, and produce better output. So coming next, we can see some related works done by prior agentic model. Some agents for web automation, we can say that WebGPT, WebGLM is the same benchmark, the previous version of this AutoWebGLM, uh, which is basically combined. Uh, these are the prior models. Basically, these are some LLMs with web environment, basically more focusing on the question answering task using the internet resources, like to as a chatbot thing, like user is asking what is this, what is that, and these models are providing the answer based on scraping the result from internet. And also, MindAct is one more another automation agent which filters the web pages through multiple choice questions. The problem is that this MindAct is requires multiple model calls, like over 10 models are calling for a single operation. This is basically very time inefficient, having more cost to handle the usage at the time of being called. Uh, and so it is very complex to use these for a complex task. It's very difficult to use these previous agents. So these are some related work. And also the famous Microsoft Web Agent, we know these, and also some of us used, like this is uses the HTML5 to process the content of the observation space, and also it is also used some previous operation and user instruction. But basically, I feel personally that this web agent previous to AutoWeb GLM model is the best model, like what I supposed or what I have seen it as a web navigation agent. uh, so it is also exhibit excellent web browsing capabilities, but faces the deployment challenges, like it is a very large model. So coming next to AutoWeb GLM, like our model, like this model, uses single chat GLM3 like model, 6B model, which is we know that MindAct is using over 10 model calls. So this AutoWeb GLM is using a single chat GLM3 6 model with a 6 billion parameters, and demonstrate the robust web browsing capabilities comparable to Web Agent. Yeah, Web Agent is also providing a good results, but specifically Web Agent model is very large in size, and that AutoWeb GLM having advantage, like offers high practical value due to its manageable size and cost effectiveness. Some of other things like prompt-based data construction methods. The methodology used for these models to generate synthetic data through prompts like Evo construct. Basically, it's just like a theory of evolution. Uh, its effectiveness, we know that it demonstrates the utility of LLMs in generating a diverse and complex instruction for various tasks. And also some zero-shot data generation. This model produces data for tasks that haven't been explicitly trained, and also showing different uh, uh, prompt-based data generation of data construction on its own versatility. So these are some data construction method by that providing the prompts. So mm, now can we can look some experiment and result as implemented method on AutoWebBench. The evolution step setup like when they are the real like the authors who implemented this AutoWebBench, then they evaluate these in this particular manner, like dividing the test set into four split: Chinese, English, in domain, and out domain. The evaluation metric used is step success rate. Like all models are evaluated with in context learning prompt. So the prompt is when given, then you can see like parameters and the models on the left side. Uh, Basically, for comparing with Llama 2 of 7 billion and 70 billion parameter, that there are like crosstalk is 3.3 for for English crosstalk, it performs 3.3 percentage of efficiency and 2.5 for cross domain. And for Chinese, it is not implemented, the Llama 2 model. Uh, we can also see, we can also see that Quen models with 7 billion parameters also have some 9% of crosstalk and cross domain of 7.6 percentage. From these evolution of step success rate, we can compare that the AutoWebGLM model is performing best with the 6 billion parameters. That crosstalk efficiency is 64% and cross domain efficiency is 58.6. Uh, Although in Chinese, the cross-talk efficiency is 65% and cross-domain efficiency is 61%. So uh, on implemented that the evolution step of on mini Wob plus plus and web arima. Basically, the setup was testing the web agent with 56 tasks with 100 evolution episodes per task. So you can see that on performing over on mini Wob plus plus and web arena. Uh, Again, the AutoWeb GLM model uh, overperformed other model like by 89.3% and 18.2 on Web Arena. So on the size is also very much comparable to all these models like Lemur and HTML5XL. And that HTML5XL is only used by that web agent and WebNT5. So basically, the uh, AutoWeb JLM model is outperforms the previous benchmarks which is presented in these navigating agent marks. So these are some qualitative results. Basically, it is the web agent result because this auto web GLM is currently in testing phase, not in production, not deployed in production environment. So they have tested for web agent, what are the results for the particular targeted task. The same things uh, given by this AutoWeb GLM model when it comes for a production environment, when it is deployed for a production environment. Uh, so now we can see when we are using this particular string, what is the weather like today? So these are the steps you can see on the right side performing by the web agent. Only the thing when it used when we are using when this AutoWeb GLM model is comes on production environment for public use or deployed publicly, then the problem which is faced by the web agent, like having very large size and computational cost, is also very much these problems are solved by that AutoWeb GLM model. And also some steps are also uh, like efficient more than this web agent. One more, you can see that shopping advice like targeted task is to help me pick a Christmas gift. Like we will give a prompt like to uh, select a Christmas gift, then definitely it will crawl to a page of Amazon or any other website which is used uh, to do for online purchasing. It will crawl basically use preferable website, but because like already well established website, but definitely it will not crawl to any fake website to give a user a confusion over it. So now let's come to a conclusion of this AutoWebGLM uh, model, which is trained with Chat GLM 6 billion parameter model. So we can see that it represents a significant step forward in the development of intelligent web navigation agents. Although it is not deployed for the public usage, still in uh, what can say in testing phase. But yeah, this is not a perfect. This is evolving solution and very much comparable to the previous version of navigation agent or other benchmarks like web agent, MindX, and other different web GPT, other different navigation agents. So when it will come to production environment or deployed for public usage, definitely it will outperform the every previous agents, web agents. So it also address some of the key challenges by using that already mentioned approaches like HTML simplification, human habit, AI data collection, like using the curriculum learning, reinforcement learning, also promise the enhancing web navigation tasks. However, some more further research and development are needed to bridge the gap between AI and human performance. Because we know that this model is not perfect. This model also has some restrictions. But yeah, it outperforms the previous model. And as the AI is keep evolving, like ChatGPT 4 Romney, ChatGPT's new version, like it is already uh, announced that ChatGPT 5 is also coming by the end of this year. So as the language model is evolving, uh, we are seeing a better future of AI and human performance in this domain. Like there will be a stage when where we are prompting by voice that perform this, and the web navigation agent and other agents, large action models or large language models are performing the particular task for human in a one go, in a one click, which is used to do by human by a lot of uh, searching and uh, wrangling over here and there in different websites performed by these large language models or large action models or large latent action models in one go. So yeah, this is the quite uh, better future we are moving as our further research goes on. Uh, it's definitely to bridge the gap between AI and human. So for the GitHub links, you can see the link of the paper and GitHub link provided by the AutoWebGLM, uh, like their implementation. uh, you can see on this link. So that's it. Thank you.